Hello guys, welcome back to my channel. It's Maths Time Questions and Answers, a channel that gives you insights about the problems giving you headache at school. Today's video we are going to be discussing modular arithmetic. So at the end of this video, I want each and everyone watching this video today to be able to tell us what modular arithmetic is, to solve problems involving modular arithmetic, to know the tips when working with modular arithmetic, how to use a non-scientific calculator to calculate the modulus of a number, and the last point, we are going to look at how to handle a past GC equation that involve modulus. So stay with me as I walk you through this video series of today. So without much ado, I am Mr. Aloge and I'm going to be the instructor for this video today. So without much time to waste, let's look at what actually modular arithmetic is. So take for instance, we are counting, as you have seen on the screen here, we are counting a number in mode 5. What do we mean by counting in mode 5? Or some people say we are counting in base 5. What do we actually mean by counting in mode 5? Counting in mode 5 simply means that what we will count from 0. Whenever we get to 5, we start counting again from 0. So we simply say that what the number is wrapping around 5. So we will count 0, 1, 2, 3, 4. As we get to 5, we start counting again from 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So the number is wrapping around itself, and this is all about what modular arithmetic, which simply is a concept where numbers wrap around themselves. So that is a definition of modular arithmetic, and this concept is very much important used today in everyday life. For instance, the days of the week. The days of the weeks are wrapping around the number 7. So we count from 1 to 7 and we start counting again. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. We start counting again. So we count them in the base 7 or in mode 7. Look at the clock, the wall clock here on your screen. The wall clock is also wrapping around what number? You are correct, the number 12. So we start counting from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11th hour, and when we get to the 12 hours, the clock initializes itself and start counting again to what? 1. So we say that what the clock is working in modulo 12. So what if we have an example? Let's look at how to handle one small example when we are talking about modular arithmetic. But before we go on to that example, I want you to figure out what day lives are using modular arithmetic, like what? The months of a year. Look for more examples and you can comment them on the comment section. So without much time, we should look at this example on the screen. The time now is 6 a.m. What will be the time 10 hours from now? So what do we need to know? We need to know where our clock, around which number our clock is circling. So if we are using a wall clock, then we expect that wall clock to be circling around the number 12. So if we are in 6 a.m. now, what will be the time 10 hours from now? So it's more logical to just put up your clock there, and then you say that what we are at 6 a.m. here, we count 10 hours from there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hours, which will give us 4 o'clock. But how actually did we get 4 o'clock? So somebody else might say that what we are 6 a.m. we add 10 hours will give us 16 hours, which is very correct. But remember, our clock is circling around what? The number 12. So instead of our clock giving us 16 hours, when it gets to 12, it will start counting 1 again, 2, 3, 4. So it will go to what? 1 circle, remainder 4. So at that point, let's now use this number 16 to get the time 10 hours from now. So if we take the 6 o'clock where we are now, plus the 10 hours from now will give us 16 o'clock. If we take this number, we can say that what we are dealing with 16 o'clock, but our clock is circling around 12. So we say our clock is working on mode 12. So what are we actually looking for? We are looking for the number 16, which is our time from now. Our clock is circling around the number 12. So 16 modulo 12, which will give us 4. How did we get this 4? 16 modulo 12 is simply means that we should take the number 16, divide it by 12. So if we are dealing with mode 12, we are simply counting from 0 to 11, which is giving us 12 numbers. So we'll have what? Mode 12 will simply be 0 to 11. When we get to 11, we are concerned with the number 16. So at 11, when we are going to the next number, which is supposed to be 12, we'll have what? We'll start counting again at 0. So we are going to have 0, which is now 12, 1, which is 13, 2, which is 14, 3, which is 15, and 4, which is 16. So 16 modulo 12 will be 4, because 16 in mode 12 will correspond to this number 12, because we'll count from 0 to 11, then we start counting again from 0, and 16 will correspond to 4. So from this example on the screen, 0 mode 12 is 0, 1 mode 12 is 1, 2 mode 12 is 2, 12 mode 12 is 0, 13 mode 12 is 1, 14 mode 12 is 2, and so on. So if the number was maybe 400, then we'll simply look and calculate it using this same method. But what if the number is too big? If it's too big, then we need another method to ease these calculations. That's why we have what? The division. So mode 12 is also simply that what? We should take the number 16, divide it by what? The modulo, which is what? The 12, and we are going to have 1 remainder 4. Where has this one gone to? So because we are concerned with the remainders when we are dealing with modular arithmetic, we say that what? Modular arithmetic is the remainder arithmetic, because we are concerned with just the remainder. We don't care how many circles it goes, we care where it is at that particular time, right? So the remainder is 4. So 16 mod 12 is 4. So we call it what? The remainder arithmetic. Our answer is 4, as here too. Okay, we have 4 times 5 mod 12. That's another example. So what we actually need to do is to multiply 4 by 5, and we take what? Modulo 12. And remember, we have said modulo is the remainder arithmetic, which is what? We are concerned totally with the remainder. So we simply evaluate the number 4 times 5 to give us 20 modulo 12. So we are going to have 20 modulo 12 is simply 20 divided by 12, which is 1 remainder 8. So 20 modulo 12 is 1 remainder 8, and the remainder is what we are concerned with when dealing with modulo arithmetic. So the answer in this case is 8. Now when the number is too big, we can use a calculator as follows. So let me pull up my calculator here and then show you how to use the calculator. Okay, we have a calculator on the screen here. Let's see how to use this calculator of in the case of 16 modulo 12. So we are dealing with 16 modulo 12 is simply 16 divided by the modulus, which is 12, and the answer will be 1.333333. So we are not concerned with the whole number. We are not concerned on how many times the number circles, which is 1 time. So I will simply take that number 1.33333 and subtract 1 from it. So minus 1, it will give us a decimal of 0.3333, and this decimal I can convert it to its equivalent integer by multiplying that decimal times the modulus, which is 12, and it will give us an answer of 4. So that remainder is 4. When we are dealing with a calculator, remember, don't approximate the fractions, else it will give you a non-integer, or it will give you something that is not accurate. In this case, that's why I decide to use all of the decimal point in calculation. So you simply take the whole number plus the decimal point minus the whole number to give you all of the decimal point, and we take the decimal point times the modulus. The next example that we had on the screen there is example of 4 times 5, which is 20, and our 20 we are using what we are counting in modulo 12, so we'll divide this by modulo 12, so it will give us 1.666. so I will take this 1.66666 and subtract 1 from it so that I can have the 0 point something 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 something, which is the remainder. We have 0.66666. I will take now this remainder and multiply by the modulo to give me the actual number of the integer value of that decimal number, which is nothing but 8. So that's how we use a calculator to calculate modulus. So let me take a much bigger number. Let's say, let me just make up a number here. Let's say 87596. What modulo? Let's say we have these are the days of a particular years, and we are counting them in terms of hours. So let's say the hours of a day, maybe 24 hours. So we divide it, we are counting in modulo 24, so we divide it by the number 24. We are going to have 36.444. Oh, okay, 36,498.541 and so on. So what we are interested in is the decimal, not the whole number. So again, I'm going to take all of this number, subtract 36,498 from it to give me the decimal, which is 0.55. Then I take this decimal times the modulo we are working on, which is 24, which will give us 13. So that's how we handle we use a calculator to calculate modulus in case we have one at hand. All right, so let's go back to our question proper. Now there are tips that I want you to gather to keep in mind when we are working with modular arithmetic. And tip number 1 is that the answer to modular arithmetic should be a positive integer. We shouldn't have a decimal number when working with modular arithmetic, and this decimal remainder should be a positive integer. Now if we have a positive integer, what range should this positive integer be? We should know that if we are working in mode 5, the numbers we expect to be the answer for modulo 5 should only be in the range of 0 to 4. So then that will give us our next tip. The answer to modulo problems are always less than the modulus. So if we are working in mode 100, then the answer to modulus problems of modulo 100 can only be 0 to 99. So it must be one number less than the modulus. So we need to know that. So if we are working with mode 12 and your answer is 12, no, you are wrong. If your answer is 13, no, you are wrong. If you are working with mode 12 and your answer is a negative number, no, you have a problem somewhere. So those are the tips that we need to take home when we are working with modular arithmetic. The next part of the question is to answer a GC equation from Additional Mathematics Paper 2, question 4 of the Cameroon GCE Board, June 2018, which says that the set S equals to 2, 4, 6, 8, and the operation star is defined as multiplication modulo 10. forms a group. So the set S and the operation star, which is multiplication modulo 10, forms a group. When you have not when you don't know yet what we mean by forming a group, you can check one of my videos on my channel. It's Math Time Question and Answers, where we talk about binary operation. Is there all about groups, identity element, inverses, and the laws for group like closure, association, and so on are well explained there. So for the purpose of this video, we'll just stick to the question and answer it. So the question says that copy and complete the table below, and B says state the identity element, C says state the inverse of each element. Okay, so we have that table there, this operation star, and the operation star, we have said that what is multiplication modulo 10. So if we are working with modulo 10, how many numbers do we expect? We expect 10 numbers, but the numbers should be from 0 to 9. 10 itself should not be included. The next point is that when we are working with modulo 10, we expect what? Positive integers. We should not have fractions as the answers to our modulus. So if we have this in mind, let's now complete the table. So the first value is 4, is 2 and 2 here. So we have 2 and 2 here, which is what? How do we handle 2 and 2? They have said is multiplication modulo 10. So if we take 2, we multiply it with 2, and we take the answer modulo 10. That's what it means by multiplication modulo 10. So 2 times 2 here is 4, and 4 modulo 10 is simply 4, because 4 is not up to 10. So 4 divided by 10 will be 0, remainder 10. If you want to use your calculator again, I will still bring up a calculator just for the sake of understanding. So we still have our calculator there. So 4 mod 10 will simply be 4 divided by 10, and our answer is 0.4. Why? Because we don't have we can simply take this number and multiply it by the modulo, which is 10, because there is no whole number here, so needless to do subtraction. Or if you want to subtract, we'll say 0.4 minus 0, which is the whole number, and it's still 0.4. So times the modulus, which is 10, will give us what? 4. So if the number is less than the modulo, then the answer for that modulus is simply that number. I mentioned it earlier. So 2 times 2 is 4, modulo 10 is 4. 4 times 2 is 8. 8 modulo 10, 8 is less than 10, so is 8. So let's fill the table. Let's begin from 2 times 4 mod 10. So 2 times 4 is how many? 8. And 8 mod 10 is, that's right, 8, because 8 is less than 10. 2 times 2 times 6, pardon, is 12, and 12 mod 10 is simply, that's correct, 2, because when we get to 9, we'll start counting. 10 will be 0, 11 will be 1, and 12 will be 2. Or if you use our calculator again, we are going to have 12 divided by 10, which will give us 1.2. We are concerned with the decimal, so we would say 1.2 minus 1, it will give us 0.2, and this 0.2 we multiply it by what? The modulo, which is 10, and it will give us the number 2. So that is that. So 2 times 8, which is 16, modulo 10, it will give us a number of nothing but 6. 4 times 2 is 8. 8 is not up to 10, so we have 8 modulo 10 is 8. 4 times 4 is 16, modulo 10 is 1, remainder 6. 4 times 6 is 24, modulo 10 is 4. And 4 times 8 is 32, modulo 10 is 2. 6 times 2, 12, modulo 10 is 2. 6 times 4 is 24 modulo 10 is 4. 6 times 6 36 modulo 10 is 6. Please use your calculator to punch this if you don't know what we are doing, or just to familiarize yourself with the modular arithmetic on a calculator. Then 6 times 8, so 8 modulo 8 times 2 modulo 10 is 6, 2, 8 and 4. So that's how we handle modular arithmetic when we are dealing with multiplication modulus, and this concept remains the same wherever. Let's now work with the part B, which says that we should state the identity element. I've said that if you have not watched my video, simply go to binary operation to know what an identity element is, the inverse, and how to get these values. There is a video on my channel named binary operations is there. Okay, so the identity element, when we look under 6, we see that the sequence of numbers begin from 2, 4, 6, 8. And when we look under 6 here, 2, 4, 6, 8. So we'll call this number 6 the identity element. So the identity element is simply 6. And the inverse of any element is what will match with the other element to give us the identity element. So what do I mean? The inverse 2 will be an inverse of what? 8, because 2 times 6 modulo 10 is 2 times 8 modulo 10 is 6, which is the identity element. So 2 is the inverse of 8. What is the inverse of 4? 4 times what modulo 10 will give us 6. 4 times 4 modulo 10 is 6, right? So 4 is the inverse of 4. What is the inverse of 6 itself? We look under 6. Where is 6? 6 is here. And what do we multiply by 6 times? 6 times 6 modulo 10 will give us 6. So the inverse is 6. The inverse of 6 is 6. So when we are under 8, where do we have 6? We have 6 here, which is the identity element, and what corresponds to that 6? 2. So we say that 8 times 2 modulo 10 is 6. Therefore 8 is the inverse of 2. So guys, that's how we handle problems like this. For the meantime, I will end here, but don't forget to comment on the comment section with problems giving you headache at school, so that we can help you give solutions to them. So remain with me, and bye bye.